So as I continue the build of the B7971 Clock project, I've got 3 of the little smart boards assembled. I don't have the microcontrollers in them yet, but 3 of the boards have been put together. We tested this board in a previous video by jumping +5 to the resistors just to turn the transistors on and light the segments in the tube. I was using an external 170 volt power supply in that video to produce power, knowing I wanted this to eventually be, a standalone clock. I know I needed to power the tubes, and looking at the current draw of the tubes, it can approach 30 milliamps with all the segments lit. And so I looked for high voltage switching power supplies and finally picked these kits from 3 Neurons. They're not terribly expensive. Let me find the X-Acto here and open one of these up. And in this video I thought we'd go ahead and look at the parts and assemble one of these just to see what the assembly's like. And of course I'll need to repeat this 6 times. So we've got the little bag here with anti-static, or a little static dissipative bag. It's got parts inside, of course. As always, I've got a container here to kind of hold the parts. I'm not sure exactly how this video will turn out since the board is so tiny. Being able to get a lot of detail down onto the board is going to be interesting. I've read through the assembly instructions a few times. The board is through hole for the most part. I think it's actually all through hole. There's all the parts. So we've got the inductor here. It was like a capacitor, but that's actually the inductor. A couple of capacitors, pin header, the MOSFET, the switching controller, a transistor, I'm assuming. It's a 2N3906, it looks like. So yeah, just a transistor. A couple of different parts here. One of these is a couple of different diodes. Let me carefully separate the leads on these that are stuck together. One of these is just an IN914 or 1N914 style diode, I believe, which is going to be this guy, and then one of them is the fast switching diode, the BAU21, it looks like. But he calls out in the instructions. I'm working on a bit of a cold here. I apologize for my voice being so rough. I printed out his instructions here for the build. As you can see, the board is pretty tiny. This shouldn't be too long a build. It'll just need to get repeated 6 times. So I thought, like I said, in this video, we'd kind of go through the build. So it can be purchased on eBay. D2 no longer comes pre-assembled on the board. D1 is the BAV21. It will have taped labels on the leads, which we have a tape label on the lead there. That's the special diode. We have the parts layout here. I'm going to go ahead and work most of these components loose. I just drop them down in here for storage. I don't know if I'll use this pin header or come up with a different way of bringing the power into and out of the board. I'm undecided. So in this case, it's going to use the board could take, well, does this design actually have the layout to take 2 different? Actually, again, this is a different layout from what's in the picture here. But the components are all labeled. So this shouldn't be too big a problem to put together. Again, that's a different picture of a different board there from the one I've got. If I remember what I read here, this design, originally happened like almost a decade ago. So it's been around a while. There's the master parts list. That again is a different board layout from the one I've got. This board's slightly smaller because the MOSFET that would go there has been removed. I remember the one capacitor was changed to a 33 microfarad from a 22. I remember reading that. 0R5, 0R5, 681 ohms. See, that's a 0.01 microfarad. That's actually going to be 6.8 puff, I believe, is what that cap is. K0, 13K7. Again, that's slightly different than the board layout I have here. But ultimately, the parts are all really the same. So working from really this parts list and the silk screen should be more than enough to get this assembled. I will, of course, verify the resistances of the resistors before I install them, just because my eyes aren't that great. So let's see, we should have 2 diodes. Let's see, D2. So D1 is the ultra fast rectifier. So it should be the BAV21 and D1. So I'm going to start with him. So that's the component you would most not want to get wrong. Find his footprint on the board. There's D2. D1, where are you on here? Got D2 sitting right there, the transistor. R3, R6, D1. Okay, I see the silk screen slightly offset. So D1 is right there. Is the BAV21. I'll just manually form the leads. The diode has a black stripe to one side, and that will of course go to the where the silk screen here, where the band is shown there. So that diode's simply going to go down in there. I bent the leads a little bit narrower for the layout there, but that's okay. There's D2. And that'll make this D1. Or D2, I mean. D1 was in a small signal diode. 1N914. Same thing. There's a indicator on the silk screen for where the black band goes. Of course, in this case, I didn't bend those narrow enough. That's fine. It'll just sit down in there. Splay his leads out a little bit to hold him in place. Oh, let me actually check the camera and see where things are positioned here. I need to try to keep things more centered on the turntable here than I have been. I know I have a habit of the project sliding off this way out of the field of view of the camera. Let me find my soldering glasses. At least that's what I'll call them. My higher magnification ones. And we will just This might actually be an easier kit if I use the little board holder you've seen me use before, but you can certainly assemble it just by laying things down. And trim away the leads. That gets us the 2 diodes, and the orientation is correct. Really, from here, there's 2 capacitors. There's a looks like that's labeled 681. Sure, this is going to be like a 103K if I can read it. And of course the light's so bit, or the markings are so small. But there's always a way to find out. So that's measuring at 10 nanofarads. So that's the 0.1 or 0.01 microfarad. So that is C3. Which is this guy right here. It'll be interesting to see if I can measure this guy. Should be able to. And that's measuring 6.6. So 0.68 nanofarad, so that's the 680 picofarad. And that's C2. And he is right here. These are both non-polarized devices. 3 neurons bent the leads on the one device here, just to make it a little bit easier to install. I'm going to solder the leads on the inside here first, then I'll straighten up the part that's kind of been retrofit. Before finishing the soldering on it, just so it's a little flusher looking. I just think it'll make a little neater install with that standing up a little cleaner. I've actually got the camera so low that I'm working in the shadow of the camera. I'm noticing that here. So there's the 2 capacitors. It's a so you have resistors. I will work through these one at a time. That looks like it is 470K, 475K, that is not the same device. Okay, I have not identified that one well. These 2, however, should be the sorry, I'm digging through the loose parts here. These look like they're going to be 5 ohms. Or 0.5 ohms, actually, take that back, 0.5 ohms, and that is. And .5. There should be 2 of these 0.5s. So there are R1 and R2. I always like to get the tolerance bands the same direction. It just makes for a little neater install. I think you hear me say this every assembly video I do. Direction to me really doesn't matter as long as it's consistent. Hopefully we'll get this guy assembled, we'll get some power on him, and look at the output. I won't call it a programmable output, it's a settable output in that you can use an external resistor to set the output voltage. Well, that did not take solder well. I'll come back to that one. I must have been hitting into the ground plane down here. I really didn't want to take solder well. Let's see what we got. Ow. My side cutters here have become magnetized, and it's rather frustrating to work with them magnetized. Not super thrilled with that. Let me give it a touch of solder up on the top as well. Okay, that flowed much nicer. As did that. Okay, I'm happy with those. There should be a 1K ohm in here. There's a brown, black, red right there, which should be 1K ohm. Even though it's labeled. Yeah, 975 ohms, close enough. That will be R6. D1, R5, or is that R3? R3. Okay. $1.1K, am I reading that right? No, 4.01K. Or 4.02, so that's R6. So that guy right there. A lot of these are pretty precision values. It's part of what it takes to get decent efficiency out of a little switching supply like this. $475K. Should be this guy. It's actually measuring about 470K. Of course, it's got the my body resistance. There it is. Without me touching the leads, that's just under 475K. I was actually touching the leads on both sides to hold the ohmmeter probe in place, which I became a parallel resistor to the resistor, making the effective resistance seem lower. And there should be a 13.7K, which here's a black orange, which is 1.3, so this should be 13.7K. 13.679, which it is. I think the tip on my JBC pencil is finally kind of wearing out. I have soldered thousands and thousands of solder joints with this tip over the years. I've got a nice selection of tips, but this is just kind of my go-to for almost everything. Yeah, a helping hand to hold the board stationary here would be nice, but that's why I have little fingers. Not a very good looking solder joint. Let's see what they look like from the top. I'm going to retouch all those from the top. Just because I don't like how any of those solder joints look from up here. It is a double-sided board with plated through holes, so technically the only reason I'm doing this is aesthetics. Let's make it look a tad bit nicer. That's really got all of the resistors in place. Maybe I will move on to which part's next here. Maybe the IC. Probably honestly should have started with him, but it's a small board. Making sure, of course, to get pin 1 to pin 1, the notch on the actual device, to the notch in the silkscreen. I'm just going to tack one pin here in place from the top. I will push him down through. Let that solder hold him in place, and we'll just walk around all the pins. I can hear a dog behind me being naughty. What are you doing back there? Somebody's in here. No, she's not supposed to be. And I will trim those leads back. They're sharp and they're long. I don't need them eventually poking through. And to, you know, whatever's going to back these when I figure out how I'm going to mount them. So it gets the IC in place. Try to get the transistor in somewhat square. Case outline matches, of course, the silkscreen. Get him somewhat square. Yes, I bent that lead back up straight with my finger, and it got rather hot. Well, it's a pretty straightforward little kit to put together. I'm quickly running out of components. That is it's a 105 degree capacitor. I like that. The gold almost makes me think it's a Nissan Chemicon. I'm not totally sure, although that M may be. Still, it's a 105 degree cap, and that pleases me. That does give some thought to long-term stability of the board. As we all know, electrolytics do fail over time. So some thought to quality components is a good thing. I will actually use the board holder for the other ones I'm going to build. I just felt like it would get in the way of the camera here for this assembly, and that will make the assembly much easier. There is the 3.3 microfarad. It's an 85 degree cap, same manufacturer. Still, I have no problem with that. In both cases, I made sure the polarity was correct. Well, if the board wasn't dancing around, this would be a little bit easier to do. Almighty inductor. Take a look for lead spacing here and find my little pair of needle-nose pliers. And I will bend the leads down to approximately 90 degrees. Sitting here wondering, is there actually a polarity? It shouldn't be, it's just an inductor, but it's got one lead longer than the other. There's no polarity markings. I think it's just the way it was manufactured. It wouldn't make sense to me that, although who knows, maybe it does. Makes sense. I'm looking at the photographs of the other boards here. See if there's a hint. And I'm looking through just the general assembly notes. Sorry being a bit paranoid, and I'm chasing ghosts here, I realize that. Yes, that lead was a little hot. Probably saw me flinch there. Is it Slightly burnt my finger. No surprise. If you don't get burned occasionally soldering, you're doing something wrong or doing something very right. And I'm going to touch these up from on top. Just to get a little bit cleaner looking solder joint. Actually, that one soldered well through the plate through. And I am down to 2 components. The silk screen indicates the orientation. I've got the metal tab on the back, and you can see the narrow rectangle there. And the silk screen, he just sits down in there. I don't know that I will be able to hold him in place well for soldering. See what we can kind of make happen here. So I just want to get him tacked in, and then I'll square him up and get him flush. All that good stuff. And really, there we have it. We'll check the orientation of the capacitors one more time. They look good. Debating whether to solder in the pin header or not. For initial testing, it'll actually make it easier to have the pin header. One of the pins tacked, and I'll come back, square it up, and solder the rest of the pins. Not as square as I would have liked. Actually not happy. The gap there, that resistor. When I bent the lead over on the resistor, it was a little close to the pin header just because of how I bent it over. So I just straightened the lead back up, and I'll trim the excess off from it here. Now, of course, I don't like how that solder joint looks because I cut through it. I'll reflow it. Now there we have it. There's one of the little switching power supply modules assembled. Really the next step is to power it up. Doesn't take too much to do it. There's of course voltage in. Well, you can see it here in the picture. Voltage in, ground. We won't be using the pulse output. The voltage out, and then the external resistor to ground to set the output voltage. The range of external resistors runs from open circuit of 45 volts to, what does it look like, to dead short. So it runs a fair gambit of resistances. I should be able to use a little resistor box like this guy. They just throw in some resistances and those run from ohms to, this will be sufficient just to program up those external resistances. These alligator leads are huge. I'm not going to make this particularly easy to do just because they're so damn big. We got some better test leads here. You are a ground. Just going to hook the ground on the resistor substitution box. I need to get a power supply output here. Sorry, I'm doing a bit of digging here to get through stuff. Let's see, power on. I have the ground there, the power input there. Really need to get one more ground to get connected over to the this probably would have been easier with breakout wires. Honestly, maybe I should have just done that in the first place. Let's step back and do this a little easier. Ground V out, power in. Ground, colors here. We have a ground here, and we have a ground here. There is the take the leads from the resistor box. And we'll just hook directly up to those. And we'll make yellow the voltage out. And I'll set the voltmeter. Volts. Will get connected into the grounds through and hook the power supply up there. This will be good enough to get ground in place. coming in through these leads. There's power in. Get things recentered here. Well, it would help if the cables would quit shifting and moving the board around. So what we've got here is power coming into the board from the power supply. Let me get the voltage set to something reasonable. Like 12 volts. It's currently not on. We've got the ground for the meter there. Bring the 120 or the high voltage output to the meter through here. Actually, and rather than do that clumsily, let me just clip on the second ground here after the meter probes. This way there won't be a chance of me shorting the high voltage out. Meters and volts. Well, hopefully there'll be no explosion. It's outputting 152 volts at this point, pretty close to what I'm actually going to want. 139, 112. So let's see, at 1500 ohms, it's outputting I'm on the low range. So there's 176 volts, but I've got labeled as 470 ohms. But basically, I can see that it's working here. I haven't looked at the quality of the power out. I know if we go to a short, it's at the 190 volts. It's maxed out about 191 volts. Which is the maximum. But now I'm getting, 176 volts there. At 470 ohm, and he shows 680 ohm to get 170 volts, and that would make sense. Someplace between the 470 ohm and 1000 ohm setting on here would be where we need to be. So, no, I'm pretty pleased with that. That came right up. It's currently drawing under 10 milliamps. Of course, I've got no load on it. I guess I could put a small load on it. I'm not actually going to. I will come up a better way here to actually do load testing on it. But no, that's pretty pleasing. Damn near reached down to grab it. And of course, it's live. That 170 volts would not feel very good. And of course, I could put a potentiometer on each one of these, a small potentiometer, and tune them all exactly. For 170 volts. I don't know if it's worth going to that much trouble. Let's see if I go over to the high range. 56 volts. As we approach what it'll consider an open here, 470K. Yeah, we're getting that 45 volt minimum. Oh, very happy with that. That was an easy assembly. It went together well. at the 170 volts I'll be running. This should supply 32 milliamps, which should be plenty with all the segments on the tube. The plan is to have an individual switching power supply for each one of the NIXIE tube drivers. I'm not quite sure yet how I'm going to mount them. I'll figure that out here at some point. But you know, the build's coming together well, I think. So, you know, it's one step at a time. It'll be nice to get this all laid out in kind of a breadboard fashion and actually move on to where the real fun is going to be, and that's the code to drive the thing and do the things I want to do with it. So I'm just going to let this sit here and run for a bit. You know, with no load, it should be fine, and I'll come back and check temperatures in a bit. With no load, it should be, you know, working just fine. It shows it's drawing about 0.12 watts at this point at 12 volts. And of course, if I bring the voltage up, ooh, that was too much. Looking to see how sensitive it is to the... So it's not real sensitive to the input voltage. I took it up to 18. And it stayed very solidly at 176. As I lower the voltage here, however, of course we're not drawing any current, and we'll expect it to have to work harder. I've just swept it from 9 to 18 volts, and the output's been solid as a rock, so I will probably be driving this entire clock with probably a 16 volt supply, an old laptop DC supply that'll give me plenty of power. A little higher input voltage will make the little step-up converters here, excuse me, work a little more efficiently. They don't have to work quite as hard. Anyhow, I hope you enjoyed this little build, and we'll talk soon. Bye.